Okay, so everything's recording and sync. Hello everyone, welcome back to my YouTube channel, and today's video is going to be a little bit different because I'm going to be doing a code run through of sort of like a tutorial on one of the blogs that I have recently written. It's about Dijkstra's algorithm, and I applied it on the map of Singapore, like the MRT map of Singapore. Just an implementation of the algorithm to find out the shortest path and the shortest distance from like one station to another. Okay, you know what? You get it when I explain it to you, right? So without further ado, let's just jump into it. Hey, let's go. Okay, before that, let me just switch off this camera for real quick. Bye bye. Right. So right now, what we have over here is just a main function. Okay, before we go on to this function, right, maybe I'll introduce you to this blog. Yeah, so this is my website that I have, and yeah, so this is a blog about this MRT map and Dijkstra. So it's just a very non-technical introduction of this project. It's my motivation of this is just like I spend way too much time on MRT, and like it's really like a waste of my time, and I want to like be more efficient with it lah. And also during my term 4 I learned about like algorithms, and like I really took interest in like doing graphs. So yeah, that's what I did. That's why I embarked on this project. Yeah, and how the map is created is that each station on this map is represented by like the object station. I'll explain this in the code later. And then each connection is being like defined by like the origin, like from where to where, the destination, and also the wait, like how long, like the time taken for it to travel from the origin to destination, right? Okay, so I mean there are quite a number of helper functions that of course you're gonna implement, and just a limitation of this model is that the code doesn't really account for like the transit time between like the interchange. So like maybe if you're at Dhoby Ghaut, like it doesn't really account for like you transferring from like east west, no, not east west, what the hell, north south line to the purple line. Yeah, so this kind of thing. So if you go to this link, you'll be redirected to this GitHub page. And if you want to try out the code on your own, so you just download as zip, and just open it in your favorite code editor, which is, of course, mine's the All Supreme VS Code. Yeah, so before we get to explaining how the map is created, we need to understand with basic few files first. So this is a vertex and edge.py, and the edge is just like your connection between like one station and another station. So you have this origin, which is just a string, destination, which is also a string, and the weight is gonna be an integer. Yeah, right. And then afterwards, okay, so we go to vertex. Then the vertex have quite a couple of attributes that you have. So it's a name, like the station name, and the color, like like blue line, the red line, or like the green line lah. Then the distance, and distance you'll find it more useful when you're running Dijkstra. So I won't explain to it late. I will explain to it later, but not now. So the edges, it's gonna be so it's gonna have a list of the edges over. Yeah, so the list of, so the edges, right, it's gonna be an array of the edge object that you have over here. So you're gonna put the edges over here, and the previous is just the name of the the previous is gonna be the object reference of a station that is like the previous station. So for example, if I'm traveling from Yishun to like Ang Mo Kio, oh no, sorry, what's the adjacent stations? Shit, Yishun to Khatib. Yeah, so so if I'm stationed if I'm at station Khatib, then this like attribute will be the previous station, which is Yishun. Yeah, yeah, it's just like it. So you have just so in this station class, you have also these methods called add edges. So just to add edges to it, because it's like that, bro. Yeah, and then so it just is a special method. So it just prints out your station, the name and the line. So it's, let's say for example, Yishun red line, or Upper Changi blue line. Yeah. So adjacency list is something that you can use to represent the connections that you have with a vertex. So for example, if you're at, I don't know, interchange Jurong East, right? Yeah, so you can go the red line and go Bukit Batok. And also, if you're going to go green line, then you can either go Clementi or you can either go Chinese Garden. Yeah, so your adjacency list of Jurong is gonna be these three stations that I named over here. So then, if you go to somewhere like Dhoby Ghaut, it's gonna be massive. And if you go to somewhere like Upper Changi, you just have Expo and oh my god, what's the other station? I don't know, Tampines East. Yeah, that's the only two stations that you have. Okay. So with this, a rough understanding of what. Oh, sorry, I forgot to mention this also. In the edge class, we also have this called reverse. So reverse just returns a new edge object that is the origin is now the destination, then the destination is now the origin, and the weight is still the same. So for example, it's just saying that like, if I were to have a edge object that is like from Sembawang to Canberra, then if I reversed it, then it will be now Canberra to Sembawang. Yeah, got it. Okay, so with this, we go to this graph.py, and yeah, so you just import stations from Vertex. So this Vertex, import station as station, and edge, import edge as edge. Okay, so just initialize a few variables like the lines, the strings of the MRT lines that you have, and then just a class no sorry array of empty array of stations and edges. Then these I decided to have these edges in isolation because it's just how my code works. Yeah. And then after that, when I make map, then I just add the edges together. Yeah, because you'll see later how I why I did in this way. So okay, so if you were to call this make map, right? Yeah, so you'll see that I call these functions that are like make blue line, make purple line, make green line, right? Yeah, so I'm creating MRT stations lines in isolation first. So for example, if I make blue line, right, so I'll just have okay, so okay, I'll get back to these later. Dijkstra. Okay, so if I were to make blue line, right? Yeah, so the first thing I do is make bidirectional. So meaning that so if we were to go back to what make bidirectional means, the explanation is over here. Where is it? Make bidirectional. Oh, did I put it at the below? Yeah, make bidirectional. So if I make bidirectional, means I take argument origin, destination, weight, and destination edges. So the destination edges are the ones that I want to append to. So like blue edges, like your green edges. Yeah. So then I make an edge object. So E1 is an edge object, origin, destination, weight, and yeah. So I'm gonna append to E1 to this, and I'm gonna append E1 dot reverse to this. So for example, if I'm doing a first station, there is make blue line, so Bukit Panjang and Cashew, and the weight is the time taken for Bukit Panjang to Cashew is 2. So I'm gonna create this edge object that is a line connecting from Bukit Panjang to Cashew, and I'm gonna append to the blue edges, and after that I want to reverse it, and then so because when you make edges, it's only one direction, and I want to make it bi-direction because you can go from like to back and forth, so back and forth, to and fro. Yeah, so what you do is just reverse it. So now it's Cashew, Bukit Panjang, 2 and blue edges also. So you already have this like 2 edges in your blue edges. So and then after that, you want to append a station. So append Bukit Panjang and the blue destination. Yeah, so the blue edges 0 just means that so because we are doing it Bukit Panjang and Cashew and then reverse and appending it to the blue edges, right? Yeah, so what you're gonna do is you want to take the first how do you say, element in the blue edges array. Yeah, I know, bear with me a while. Okay. So then after that goes to for loop. So for I and range length blue stations -1, so it just means the blue stations. Where are the blue stations? Yes. So because we added Bukit Panjang already, so we're just gonna start with Cashew and go all the way to Expo, right? So then okay, so for yeah, so for for these elements, we're gonna make every like edge, we're gonna make every edge in the blue line lah. So you have this like the first station, which is gonna be if a for loop is I is 0, then your blue station, the first blue station is gonna be cashew, and the next is gonna be I don't know, what is it? Oh my god, Hillview, sure, yeah. So Hillview, so cashew, Hillview, then after that you're gonna have this blue times. So the blue times is just array of the time taken, and you're gonna add it to blue edges. Yeah, so you just keep on and on and on and on about this thing until you make every edge in your graph. And so after that, you just make the edges only. You still have to make stations. So I have another for loop. So for I in range 2 blue edges, so like the blue edges, the array, and I'm gonna have a step size of 2, because the thing is, so the way I coded is the way I coded it is it's gonna have the array appended in a very how do you say, like alternating kind of sequence. So let's say for example, if I make bidirectional, then Bukit Panjang and cashew. So my first edge object, the origin is Bukit Panjang, and the second is cashew. And then after that, my third one is gonna be cashew and cashew, and my fourth one's gonna be Hillview, and the fifth one's gonna be Hillview. And so you can see that I'm double counting the stations if I were to iterate all in sequence, and don't have a step size of 2. So what I do is that I want to jump over so that there's no double count. Yeah, so I'm gonna start from 2, then after that I'm gonna have stations append. So what I have over here, I want to append the blue edges origin, how do you say, attribute of this blue edge, and the line, the color is blue, and edges. Then I'm gonna add, so the blue edges is gonna be so for example, if I'm at cashew, I want to add the edges from cashew to Bukit Panjang, and from cashew to Hillview, right? Yeah, so I want to have it -1 and I -1 and 1, because you'll be referencing. Okay, so in this way, right? So in this way, I'm actually adding something that is originated only in cashew and to, you know, other stations in the blue line only. So yeah, this is just for the blue line, and after that I'm gonna append this because if I were to go this for loop, it wouldn't add the last station, and the last station is only one edge that is, you know, like there's only from how do you say, Expo to oh my god, Upper Changi in the blue line. Yes, I'm not counting the interchanges yet. So yeah, so that's how I make the individual lines at first. And after that, so I just do it for the green line, the blue line, the green branch. So the green branch is just the very small Tanah Merah, Expo, and Changi Airport. Yeah, then after that, so making interchanges, it's a bit tricky. So let's say I want to make an interchange Jurong East. So I'll get ID of the Jurong East. Then after that, so I'll iterate in the stations. So the stations, by default, it's going to be double counted, because the thing is, so for Jurong East, you have one Jurong East in red line and one Jurong East in the green line. So yeah, and so we're just gonna gather these IDs, and how the IDs in terms of like what position are they in the array stations. And after that, we're gonna have these temporary array called edges, temp edges, and for all these stations that are duplicated, we're gonna collect all of their edges, and we're gonna add on to this, append to this. Then after that, we're just gonna make a new station that has all the edges and like the attribute like for the color is gonna be interchanged, and we just have 600 distance, and the name is just going to be, you know, whatever the station you're doing, which is Jurong East in this sense. Yeah. So how do I? Okay, so this brings us to this main function. I just make map. So I make blue line, I make purple line, green, red, green, branch, circle line, branch, then I make interchange. Right. So then after that, I'll just add on all the edges because I did the edges in isolation, and then now I'm adding on. So then a bit of helper function. So search string, right? Yeah. So such string is just going to be you're gonna input a string. Let's say in your main py. Okay, so I'll just go through like this. Okay, so let's say I don't know how to spell I don't know, like tankaki. Yeah. And yeah, I want to know like the exact spelling of tankaki, so I just put TAN. So the capitalization must be exact, just because if it's not, then your code wouldn't run, or like it'll give you empty array. Yeah. So if I go to the done, then I just run this. Hold on a second. Okay, I don't want to run this as of now, so I'm just gonna comment this, and hold on, so that I won't yes. So if I were to search done, then it returns me all the station names that has like contains tan. So you have Tankaki, Tanjong Pagar, and Tanah Merah. So nice. So now I know how how is Tankaki spelled, and yeah, so that I know that Tankaki exists lah. And also the next thing is gonna be adjacency list of. So the adjacency list is just a representation of the edges that your each vertex have. So let me explain this. So let me not explain this, and I'll just demonstrate to you. So get adjacency list of Tankaki. Nice. Okay, nice. If I were to run this, so this returns 6th Avenue and Botanic Gardens. So how about we go to the MRT map and see what is there. Okay, do I do this? Oh, Jesus, this is way too small. What's going on? Okay. Why are the resolutions so shitty? Jesus. Okay, I think this is alright. So if I were to go Tankaki, it's here, 6th Avenue and Botanic Gardens. So this just returns the adjacent stations that you have. So maybe, for example, I try with Canberra. It return me Yishun and Sembawang. Nice. Yeah, so that's how the code works for get adjacency list of. And yeah, this is just to see what are the neighboring stations that you have, and the get index of station is just it's not helpful in terms of like getting relevant information for yourself, but for the code it really helps. So for example, graph dot get index of station, let's say Yishun. Okay, then if I were to run this, okay, okay, so I need another argument ls. So graph dot stations. Okay, if I run this again, nice. So so this returns me so this code is saying that if the station Yishun exists at like the 70th element of the array stations. So for example, if I were to just graph dot stations and I want to access a 70th station of the thing, I will get Yishun, red. Nice. So that's how this get index of station work. So this is really helpful if you're getting the ID of the station. Yeah. And okay, finally we are going to do this. We're gonna try and explain Dijkstra. So Dijkstra algorithm, you can just search over here. So it's just to so the premise of this is to find the shortest path in a non-negative directed graph, right? So what does it mean? Non-negative just means that you can't have negative weights. So in this case, it applies to us because we are having a MRT map and time is not negative as far as I know. And yeah, so this is just a pseudocode. I kind of just implemented this like a pseudocode and adjusted accordingly. Yeah. So I'll try and explain to you what this pseudocode is telling. So function Dijkstra, okay, so you have a graph and a source. So the graph is just like the map that we have, and the source is your like the source where your origin is. So maybe I want to travel from Yishun, so to somewhere else, then my source will be Yishun. So for each vertex v in graph of vertices, so what does this mean? So each vertex v just means that it's a station, yeah, in our case. So for each station in all the station array that we have, we're gonna have all this to be infinity. So what I do is, okay, maybe I should have side by side. Yeah, maybe it helps. Yeah. Okay, so you don't need this, how do you say, you don't need this thing as of now, terminal, oh my god. So you don't need terminal, so yeah, I'll just explain to you. So, okay, so for each station that you have in the vertices, we're gonna have this initialization that is so the distance is going to be infinity and the previous is going to be undefined. Yeah, so previous is just the previous station, and the infinity you can't really hard code it. You can hard code it over here, but the thing is I have to import like something, then like, yeah, I don't want it, so I just put 600 because there is no way that getting from a station to another station using an MRT would take 10 hours. Yeah, so 600 is like, okay, 60, okay, say there's 60 minutes in an hour, so like, okay, 60, then like 600, so like 10 hours. Like, there's no way you can travel from one station to another in like, I don't know, 600. So it's as good as infinity. So then what you want to do is you add the V to Q. And then we're gonna have the source node to have the 0 distance, because you travel from Yishun to Yishun is 0 minutes. Oh my god. Yeah, so that's a base case that we have. And we're gonna do this algorithm, so this first 7 lines is just like initialization, so like setting up but before you do anything. So the first line of the algorithm is while Q is not empty, you're gonna do assign this vertex in Q, which has the minimum u distance to be u, yeah, minimum distance to be okay. Then you're gonna remove u from Q, yeah, so you remove u, and for each neighbor in u, each neighbor v in u, which in our case the neighbors are gonna be I in, yeah, the edges, yeah, and we're gonna get the ID of the index of the stations, which is going to be the destination, and in the array stations. And yeah, we're going to do this something called relaxation. So the relaxation, I'll just explain it quite briefly. So the station ID, the distance, so it's going to be, so for example, if the first iteration I'm going to travel from Yishun to, say, Canberra. Yeah, so if I were to travel from Yishun to Canberra, so the Canberra, okay, so Yishun's distance is going to be 0 and Canberra's distance is going to be 600 because I haven't updated it yet. So let's say, okay, so here, so if station ID dot distance is greater than u dot distance plus I dot weight, so this means that if the Canberra's distance is greater than Yishun's distance plus the weight of getting from Yishun to Canberra, which is gonna be 2 minutes, for example. Yeah, so since 600 is greater than 2, obviously, yeah, so we're gonna have this 600. So we're gonna have this attribute of Canberra, the distance, to be 2, and we're gonna have this previous station of Canberra to be Yishun. Yes, your U is Yishun in this case. Then after that, so we just relax for every node that we note as in, so we just relax. So we just go through this algorithm for every station in our map, and your out is going to be just empty array first. Then you're gonna have get an index. Okay, you get an ID, then the current station. Okay, ID. Then after that, what I want to do is backtrack. So you want to backtrack from, okay, so for example, if I would go from Yishun to Yio Chu Kang, then my destination is gonna be at Yio Chu Kang. So my okay, so I backtrack. So the previous of Yio Chu Kang is going to be Khatib, and previous of Khatib is gonna be Yishun. Yeah, so so that's how you do it. And if you were to append this in this way, so you have Yio Chu Kang, Khatib, and Yishun. But the thing is, you want to have it in a forward order and not a backward order. So what I do is just return the reverse of the array lah. So I just have the step size -1. Yeah, and I also added asterisks to the stations that has that is interchanged lah, so that people know that, oh, you might take a bit of longer time on this. So with this, I'll just demo how the code works. So okay, then I want to comment. Okay, I want to delete this first, and let's say, okay, so I just need this, and I just need this. So let's say I want to get from Yishun, no, that's not how I spell Yishun, Yishun to let's say Rocher. Yeah, because I want to go Sim Lim Square buy stuff. And okay, so Yishun to Rocher also. So you'll see that there are two different functions here: get shortest path and get shortest time. So get shortest path just returns you the array of the path taken, whereas the shortest time is going to return the integer of the time taken by traveling the shortest path. Okay, so if I were to run this, I will get hold on a minute. Okay, so I'm gonna go from Yishun, Khatib, all the way to Bishan. Okay, Bishan, then Brother, Toa Payoh, Newton. Then I'm gonna change to Blue Line, I suppose. Yeah, so Newton, Little India, and Rocher. So it's gonna take about 25 minutes. Right, so maybe I should get something that is a bit more, how do I say? That's something I do quite often. So Upper Changi to Jalan Besar. Yes, I think that's how I spell it. Okay, maybe maybe I should double check. Okay, then I have to comment these two first. Okay, Jalan. Yeah, that's how I spell it. Jalan Besar. Nice. So Upper Changi to Jalan Besar. Okay, Upper Changi, Jalan Besar. Okay, so just do this. Run again. And yeah. That's about right. Yeah. So maybe I should try and break the one last time. I don't know. I want to go from Serangoon to something like, oh my god, Tanjong Pagar. Tanjong Pagar. Serangoon to Tanjong Pagar. Then, okay, what is it written? So I go Serangoon, all the way to Dhoby Ghaut. Okay, so the purple line here. Then after that, it's gonna be City Hall, Raffles Place, and Tanjong. Oh no, Green Line. Yeah. Okay, so I changed from purple line to green line. Makes sense, right? Yeah. So and it's gonna take about 60 minutes. So yeah, that's about it. Actually, for the tutorial, I guess. I hope this is not a very long video. I still have to do quite a bit of editing, and yeah. So if you want, just go check this GitHub page out, and just download the code, and you can play around with it, and yeah. And please do let me know also if there are any like questions regarding this project, or there are some things that you still don't really get it, especially making the map itself. It's quite challenging for me to get it first, get it also. Oh yeah, with this, we've come to the end of the video. I hope you enjoyed it. Leave a like and comment and subscribe down below, right? So I hope to bring you more like computer science, like project kind of videos as well, and also like maybe skits, because I still love doing skits and stuff like that. So yeah, just let me know in the comments what kind of videos you want to see from me, and I'll see you in the next video. Peace. Ha.